So yeah, like I said, welcome. Quick April retrospective. Thanks for everybody who was able to join us for that. It was our first virtual meetup in kind of the new world here, and I think it went really well. Um, we definitely got some good feedback that people kind of like having, the option of attending these virtually during the workday as opposed to after hours. So, it's a good new way to reach maybe more of our audience who can't always make it physically to our on-premises meetups. And so we're obviously going to keep going with that for a while here. The talk is available on our Cloud Native Madison YouTube channel. So go ahead and take a look there. If you subscribe, then you'll get notifications whenever we publish those out, and we'll be publishing today's recording out there as well, of course. So looking ahead as far as the meetup goes, we are going to remain virtual through June for sure. We're taking the month of July off. We typically take the month of July and January off just because we have major holidays in that first week there. So we'll be getting back to things in August, and we'll be making decisions probably in July around whether that will be virtual or on premises, depending on how things go here over the coming months. But like I said, we've been really happy with having these virtually, so we'll be sure to continue to bring the good content out for these virtual meetups. Speaking of which, our June meetup is the first Thursday of next month, June 4th at 12 p.m. Central. Same format as we have here today and had last month. And we're in some kind of just buttoning down some details, but it looks like we are going to have a talk on serverless workloads with Knative from somebody at our partners at Google. For those who may not be familiar, Knative is a serverless framework for running serverless type workloads on top of Kubernetes itself. So you can do things similar to what you might imagine doing with something like AWS Lambda, Google Cloud Run, or Azure Cloud Functions. But being able to bring that into your own kind of managed Kubernetes clusters so that you can kind of manage those workloads side by side, but give your developers that more platform as a service like feel as far as their development. So we're looking forward to that next month. Some quick notes about what's been going on in the cloud native community in the last month or so. So we've had two projects kind of move up the graduation continuum within CNCF. The first one is Helm, which is sort of the package manager for Kubernetes. So kind of the analog to apt-get or Yum or Homebrew, if you're familiar with those things, manages being able to easily install software to Kubernetes clusters. And that came all the way up to the graduated level. And if you see on the bottom there, there's a diagram of the CNCF's sort of maturity model and how they actually look at these projects when they move from sandbox to incubating and then ultimately to graduated. And so graduated really means like this is totally enterprise ready, that the community's proven it out. There's been security audits, sustainability audits. There's a good governance model in place around the project, so it's not tied to a small set of individuals or one company or anything like that. And in fact, looking back at the yearly CNCF survey that we talked about last month, actually 70% of respondents to that survey who are using Kubernetes are using Helm in some way to deliver software to their clusters. So obviously, it's good to see that we're getting even more projects up at that graduated level within the ecosystem now. The other one I wanted to call out is Argo, which is a continuous delivery system specifically built for Kubernetes that follows the sort of GitOps model of managing those definitions of what you ultimately want to be running in your clusters. For those who have been attending these, you may remember us talking about how it was announced at the Cloud Native conference in November in the US here that Argo was merging with a similar project called Flux from Weaveworks. And they're both kind of trying to do the same thing, which is bring a GitOps workflow to continuous delivery for Kubernetes. And so Argo moving from sandbox up and incubating shows good progress with the momentum of that project. And that seems to kind of becoming the de facto way to do GitOps-based delivery to Kubernetes clusters. So if anybody out in the community here in Madison is working with Argo and would be interested in giving a talk on it, I think that's something we would all be very interested in seeing. A couple of notes around some new interesting features that have been rolled into the managed Kubernetes offerings out in the main cloud vendors there. So the first one I wanted to mention is that Windows Server containers have actually gone GA for both Azure Kubernetes Service and Google Kubernetes Engine. And so that means that while certainly in the Microsoft ecosystem, you can build using .NET Core for Linux, you can now also bring anything that would typically run on a Windows server into a Kubernetes Windows pod. And the exciting bit there is that it makes organizations able to bring legacy applications that are already built in frameworks or runtimes that require Windows into Kubernetes without having to go through a bunch of redevelopment or refactoring, so that you can actually use .NET Core for those services. So that ultimately expands our ecosystem quite a bit in terms of the types of applications that you can run on Kubernetes itself. Another major announcement was Google Anthos has released their AWS support in GA. And for those not familiar, the idea of Anthos is that you can have your Kubernetes management plane run by Google for you in a totally managed sort of way, the same way you would with Google Kubernetes Engine. But the execution nodes, those servers that actually run your pods, can be essentially anywhere else, from on-prem to another cloud provider. And so that support is integration so that you could have essentially a footprint where you're managing the cluster in Google, but you could actually have your execution nodes over in AWS. And for a variety of reasons around sort of inertia in a certain cloud or governance, or just wanting to diversify where your deployments are running for things like availability or disaster recovery, that is a very interesting feature to me for sure. Another really cool feature is Azure Kubernetes Service has released support for building node pools in your Kubernetes cluster out of spot instances. And so spot instances or preemptible instances are essentially servers that can be spun up on demand when there's excess capacity within a certain region of a cloud provider, and typically at extremely reduced costs, like up to 80% cheaper than sort of a dedicated server. So this becomes really compelling for services that are sort of batch style, where the amount of work you're doing at any one time can kind of scale up and scale down, but it's more important to efficiently be able to churn through as much data for as cheap as possible. And so machine learning workloads, batch workloads fit really well into those kind of things, and that is now natively available for Azure Kubernetes Service. And then finally, another interesting thing is AWS's managed offering, EKS, launched support for ARM nodes in their node pools. And so if you're not aware, Amazon has actually been doing a lot of custom work for ARM-based processor architectures. And they have currently EC2 nodes available on these new processors that are, again, drastically cheaper than Intel or AMD-based nodes. And so for anything where you don't need really high-level single-threaded performance that Intel and AMD can give you, if you have more kind of a scale-out, horizontally scalable compute needs, those ARM nodes can actually give you quite a bit of performance for much, much less money than an Intel or an AMD-based server. So ultimately, all these things are, cloud providers bringing sort of unique advantages to their managed offerings, and things that you certainly could do with a bit of work if you were going to create your own clusters on the raw virtual resources that they provide. But it's interesting to see how much they're kind of bringing those extra features to bear on top of their managed offerings now. That might be a little bit more difficult if you're doing your own clusters. And then finally, wanted to announce that Cloud Native Computing Foundation has opened up their call for proposals for their conference this coming November, the North American Cloud Native Con. Proposal windows open now and ultimately due June 12th. And I think they usually announce the speaker lineup in August or September. That's currently scheduled to be on-prem in Boston. However, as things evolve, we'll obviously see if that goes virtual. The European conference, which is in August now, did go virtual. So one way or another, if you're interested in giving a talk there, encourage you to go ahead and put in a CFP. As somebody who's attended a lot of these cloud native conferences, I think one thing that's often missing there is sort of more kind of stories from the wild at smaller, medium-sized companies, kind of end-user companies who are living in the cloud native ecosystem. And a lot of us have good stories to share there. So I do encourage you to think about whether or not you can potentially present something at that conference. Finally, want to thank our sponsor today, LogsIO. LogsIO is a open source based observability company. And as you can see there, their tagline is kind of the open source you love at the scale you need. And so we at Integral have been using LogsIO for many years now, and they've become a critical piece of our observability pipeline. Everything they do is based on open source technologies, and they really focus on operating those technologies at scale, so you can focus on using those technologies rather than figuring out how to run them at kind of production scale, and really kind of focus on how do you deliver more value to your business. So with that, I'm going to turn it over to Ashley Somerville and Roy Nuriel to give our talk today.
Thanks. Can you guys hear me?
Mm-hmm.
Okay. Okay. Can you guys see my screen?
Yes.
Yes, we can.
So thanks for the introduction. My name's Ashley Somerville. I'm joined by my colleague, Roy Nuriel. We both are from LogsIO. I am a customer success engineer, and Roy is on our product management team. So we'll be pulling from our experience of working with many different companies, who run different infrastructures on various cloud providers every day for their observability stacks, and giving the talk today, which is designing an open source observability stack for distributed environments. Roy and I will be tag teaming the talk. So we'll start with Roy, who will go over what is observability and why should you care. Then we'll go into Kubernetes and how the adoption of Kubernetes has impacted observability. Telemetry success and how open source plays a part in that. Then we'll talk a little bit about security's role. We feel that security is somewhat a neglected piece of the observability platforms. So we'll go through that, putting it all together. And then we'll actually show you some of the open source tools that we'll discuss today in the LogsIO platform, so you can see what those look like. Okay, Roy.
Thanks, Ashley. Thanks, Ashley, and thanks, Brandon, for the introduction. And I'm happy to join you guys today. Thanks for the opportunity to share with you a little bit about what we see in the market and potentially how you guys can take some of those components and deploy them and be more efficient on your daily work. So before we go into the architecture and the components, I want to share a few trends that we see that I think are very relevant and interesting to understand how they impact the observability need. The first one, which kind of is connected to what Brandon mentioned before, we definitely see companies moving towards the cloud. So that's not new for anyone. The interesting thing that we see, and again, it kind of relates to what Brendan mentioned before, we start to see more multi-cloud strategy. So organizations that started with AWS, for example, now want to make sure that they find, because the overall cost of the cloud became extremely expensive, they're trying to find alternative. They want to make sure that they spread the risks. And that's kind of one aspect that we start to see growing significantly, which is very interesting. The next one is obviously, I think you guys as a community talk quite a lot about modernized application, the fact that most applications are now being developed as a microservice application, a lot of containers, Kubernetes, Dockers, etc., all over, which really makes the life of developers way easier. So now as a developer, I don't really need to think about all the implications of deployment, etc. But on the other hand, the people who really needs to monitor the application and handle the application in production, for them it's way more complex. It's dynamic. It runs extremely fast. It's not persistent. Ashley will talk about some of those aspects later. But at the core of all of that, what I think that really changed the landscape of monitoring and observability is the fact that we have a new persona that really looks into monitors. So if I'm in this industry for quite a lot of time, 10 years ago, 15 years ago, there were the developers. We finished doing our job, then we sent it over to the operation team. In many organizations, we didn't know each other. And there were the people in the operations side that they knew how to run and operate that. Where with modern application, we definitely see that ownership moved from the DevOps team, from the IT and the operation teams into the DevOps teams. And the DevOps obviously are much more closer into the development teams. They work as part of the same organization. They have the same skills and expertise as developers, and it really changed their needs, how they look on how to monitor application, and as part of their ownership and their daily work. I want to share with you, and that's the next slide. There's a survey that was done by Google that really shows that the DevOps really crossed the chasm. And what it really means that we see more and more continuous delivery. I can share with you that internally at LogsIO, we release multiple times a day. So we need to make sure that our release train is robust, it is fast enough, and we can constantly know what's going on in production while we're pushing those changes. So developers has a lot of power, and together with power, it comes a lot of responsibility. So now if there's an issue in production, there is a developer on duty that will wake up at the middle of the night in order to answer or address issues in production. And that's one significant change, unlike a few years ago. The other thing that I think is very interesting and what we see as kind of ones that really engage a lot with the community, developers or DevOps tend to go to open source as the first place when they look for a solution. So also I've been a developer. Usually when I had a need, I either went looked for kind of libraries that are available, open source that is available. We believe and we know that if we look at the next big thing, we know a few things. We know it's going to be most likely run on the cloud, which allows companies to move extremely fast and run and be very scalable. And most likely, it will be based on open source. You guys talk a lot about Kubernetes and those aspects. All of those are open source technologies that are kind of leading the technology stack, and most likely it's not going to be based on proprietary company. So let's move forward. I don't know how many of you are familiar with the term observability, and one of the challenges with those virtual events that you cannot really see who you talk with because it's kind of challenging. But I'm curious to know how many of you are familiar with the observability term. And when I looked at the good definition for observability, I think the Wikipedia definition is something that I can really relate to, which is observability is a measure of how well internal state of a system can be inferred from knowledge of its external output. And that's the core aspect, which is how can we know the state or the health of the application based on outputs that the application provides. And that's kind of the essence of observability. Every system that we know has those outputs, and we're going to talk about software and those three pillars of observability that we see in our space. So observability, it's basically built up of three pillars: logs, metrics, and traces. We usually see logs as the first one that the organization tackle. The main reason is that every application has logs built into the application. Logs can be better than others. It really depends on the developers and how they develop the code. But those are really easy to collect on one hand, while on the other hand, it's really it's more complex to really understand what's going on there. Million lives of logs, and more so when there's an issue in application, we see a spike in the number of logs. Usually each one of the component influence other components. There is a kind of a mass number of logs that flood the system. The second one is metrics that we usually see. So organizations tend to start with logs, move to metrics. And metrics, there are obviously multiple types of metrics that you can look at. The basic one, the infrastructure that are there, such as CPU, network, memory, etc., that really helps you to know the health of your infrastructure and how ready it is in order to scale and address load, etc. And the other one are more custom metrics, things like metrics that the application will send, number of errors, the time it takes to log into the application, etc., that you can really look into that. Usually the challenge with metrics, it gives you a good indication that there is a problem in the environment, On the other hand, it doesn't provide you enough information in order to know what's the root cause of the problem. So you really need to have a combination of both logs and metrics in order to continue the investigation and find, once you have an indication that there is a problem in the application, really deep dive and understand what's the root cause of the problem. And the third pillar that I think it's also related to maturity and how we see organization is traces, also known as application performance monitoring, APM, where it's the ability to really measure the performance of components, how much time it takes, for example, to log in, and really see all the traces, the breakdown of all the transaction and how it handled the backend, which really helps you to find how you can improve performance. Usually it's way more complex. We're going to talk a little bit about that. Really understand how to instrument the application, how to gather the information, and kind of understand what should be the action item. So let's move forward. Common impediments that we see in observability, and I think the first two are very kind of straightforward. So obviously, if you're not collecting enough information, that it's not really useful. The same goes that, you know, if you're collecting only information that is not actionable, it's kind of the similar. And those are kind of very intuitive. I think that if we look at the distributed application, containerized applications, then the other two are actually very interesting. The first one is collecting too much information, really create a lot of noise and complexity in understanding what's relevant and what's not relevant. I don't know how many of you set a Prometheus instance together with Grafana. Prometheus really integrates really nicely with Kubernetes, and it immediately floods your environment with a lot of metrics, and you need to understand which one are relevant, which one are not. But it's really easy to gather millions of metrics and really get confused by that. The second one is really fragmenting access to information. Ashley will talk a little bit about, you know, how dynamic the environments are. We have data that comes from multiple environment, multiple regions, pre-production, post-production environment, and really know how to organize the data and the metrics in a ways that it will be something that will be actionable. I think is a significant challenge that we see. So let's move forward. And I want to kind of hand it over back to Ashley to take us through the Kubernetes complexity.
Thanks, Roy. So we've seen a number of challenges introduced due to the rapid adoption of Kubernetes. And every year, LogsIO sends out a survey to a few thousand engineers, DevOps engineers, to understand trends in the industry. And one we did recently was the adoption of Kubernetes. And what we found is that it's being adopted up to 6 to 7 times faster than cloud adoption. And with that, a number of complexities are introduced that you need to be aware of. The first one, and probably the most important, is dynamic. So containers are immutable, they're ephemeral, they run, they start, they upgrade, they're restarting. They have all of these different states that they can be in. And if you think about a time that you had a problem, if you're running Kubernetes, the whole pod goes down, it comes up, and if the container restarts, you lose the logs. So the key to this is data persistency in real time. If you're not persisting the data, then the data is gone and you can't troubleshoot what the root cause of the issue is. This is especially important when you're running in multiple clouds, you have multiple clusters, multiple environments. So with the constant upgrades, Roy mentioned we're deploying at LogsIO ourselves sometimes 100 times a day. So this data persistency for understanding trends and what's going on is the key. The next is distributed environments. So like we already talked about, multi-cloud is a trend we're seeing in the industry, running on AWS, GCP, being deployed in multiple cloud regions, both on-prem and cloud. So we have clients who are running Kubernetes on-prem. Being able to have data flow seamlessly in between all of these different pieces, it's abstracted and it's transparent. A look inside LogsIO's environment. So we're deployed on AWS and Azure, 7 regions in AWS, 5 in Azure, and the data is constantly flowing between. We have issues. We need to be able to identify those problems and resolve them quickly. A look at this image we have here. So we have the traditional architecture, which I'm sure everyone's familiar with, a monolithic system. When this was the normal architecture for the industry, it was easy to troubleshoot problems. You SSH'd into the server, you read the logs, you saw what the problem was, and everything was great. Then we've added on the containerized architecture, so Docker containers. As Roy alluded to, this makes it easier for developers to develop code. We can write code, we can deploy. We don't have to worry about where it's deployed. It's totally abstracted. So this is good for developers, but it adds on the layer of complexity for actually observing your environment. Kubernetes, the next step, orchestrating these containers. This adds multiple layers of complexity, multiple application servers. We're upgrading, we're scaling. Developers are just writing code and deploying. So when an issue comes up in the infrastructure, we need to still be able to monitor that. Okay, and the last thing, verbose and noisy. So there's millions of log messages and data points that are coming in from your Kubernetes clusters. The moment you connect Fluentd, connect Prometheus, you're flooded with information. So it goes from finding the needle in the haystack of a monolithic system, one log file, to sifting through millions of log messages and looking for the root cause of the issue. Especially when things break. So I'm sure everyone's familiar with when one thing breaks, you suddenly have your support lines ringing. There's connection exceptions, there's latency. So being able to quickly find the root cause of the issue, either rollback or hotfix, is extremely important. So telemetry success and why open source is the solution. There's a survey that was done by Datanyze, which says that 85% of companies are using open source for monitoring. So you'll see some of the common open source tools here on this slide: Kubernetes, Jaeger, Grafana, Elastic. And like Roy mentioned, if you think about the next big company, the next big thing, we don't know what it will be. Nobody predicted Netflix, Uber, all of these big companies, but we do know a few things. Like Roy said, we know that it will be a software company. Everything today is a software company. And we know that they'll be deployed in the cloud. So they're the next big company. They need to scale. In order to scale, they need to be deployed in the cloud. And we also know that they'll use some sort of CI/CD, so continuous integration, continuous deployment. And by definition, that means that they'll be running Kubernetes and Docker. Since they'll be using Kubernetes and Docker, that by definition, those are open source tools, and they're fully integrated in with open source monitoring tools. So at least in the beginning, we know this next big company will be using open source for their monitoring. Okay, so open source, what's so great about open source? Why open source is the solution? First of all, it's accessible. So it's available, it's readily known. You can go on GitHub while I'm doing this talk and probably deploy an elk stack, deploy Prometheus, Grafana. It's easy. The hard part is scaling it. And it's really fun to stand these up. Community. So there's a huge community behind all these open source tools, and that is good for employers because when you're hiring people, if you're using open source, the onboarding time shrinks down to close to none. This community also develops different content. So there are so many Grafana dashboards, Elastic, Kibana dashboards out there that are already built to solve the problems that developers are having because it's open source. It's DevOps native. So this goes back to who's actually developing these open source tools. They're DevOps engineers. So they're written to easily integrate with other open source projects. You deploy Kubernetes, it's one line of code and you have Prometheus. And it's cloud native. So same thing, these DevOps engineers that are developing these open source projects, they're working in the cloud. So these projects that they're building are often built for monitoring the cloud. Okay, and so we put together an open source observability toolkit. So these are some of the projects that we see used the most in the industry. So for logs, the elk stack is definitely the most prominent that we're seeing today. It's the most common. and it's dominant. Elasticsearch, Logstash, Kibana, and Beats. We've definitely seen a large increase in adoption of FluentD and FluentBit as a shipper and transformation. And that goes hand in hand with the adoption of the cloud. Low-key, from the folks at Grafana, we see this from time to time. It's a good project, but the Elk stack is definitely the most dominant. For metrics and monitoring, Prometheus is definitely the number one we see. It's the most popular, it's native to containers, and it's the best solution for dynamic cloud environments. It was built for dynamic cloud environments. Graphite, we're starting to see less of, but still a good project. InfluxDB, definitely trickling down. And from time to time, we also see Elasticsearch as a database. And the reason is, it isn't because it's the best, but companies are used to standing up an Elasticsearch and running it at scale. So if they're already used to that, they'll just use it for their metrics. And Elasticsearch is actually releasing frequently better support for metrics in real time. Grafana, the number one front end is definitely Grafana for visualizing the metrics. Tracing and APM, we've seen adoption of tracing more so recently. The two leaders are Jaeger and Zipkin. They're both part of the open tracing community. Jaeger, we definitely see increasing more rapidly as of late. And this is really because it also supports the Zipkin format. So you can have a Jaeger server and it will also support the Zipkin format.
Ashley, maybe before we move to the next slide, if we can go back to the previous one, a few things that I wanna add on top of that, if I may. I think that what we start to see, which is very interesting, both Elastic, the company behind Elasticsearch, and Grafana Labs, they both of those companies are trying to expand their offering to a full observability. So, for example, Elastic just announced in the last ElasticCon that they're going to support PromQL, which is the language, the query language for Prometheus. Obviously, they expand their solution also for metrics in the future, and they're looking at ways that they can make their solution more robust. Although the Elasticsearch database is not really geared for metrics of a solution, and it has a lot of gaps that if you're going to use it, you need to be aware. Things like rate function, etc., that are not supported in a seamless way with Elasticsearch, unlike Prometheus. While on the other hand, if you look at Grafana Labs, they're now expanding the offering to add additional capabilities for obviously Loki, the project that provides the ability to correlate logs. They add the dashboards for logs, and they're planning to add the ability to integrate Jaeger into that offering. So I think that everyone understands that the need is not only to provide the point solution to address one of the pillars, but really to provide the ability to tackle all of those pillars, because once you have issue in production, you really need all those tools in order to, one, know as quickly as possible that there is an issue in production, and two, have the right tools in order to solve and fix them as quickly as possible. So those were my kind of few additions on top of that. So we can move to the next slide. The next slide is it's basically the basic architecture of the observability stack that Ashley mentioned before. If we're looking at logs and tracing, so you need to have Beats or FluentBeat, Jaeger as the main shipper that will ship the data into Elasticsearch. On the other hand, if you're working with Prometheus as your time series database for metrics, Prometheus know how to scrap the metrics automatically and basically populate the database. The leading front end is Kibana for logs and Grafana for metrics. Although, as I mentioned before, you can definitely see kind of teams that use Grafana for other purposes, which are not only observability, and you can also use Kibana for metrics with metric bit. It's more limited. It's not. It doesn't provide the best user experience, but it's definitely there. We do see Graphite and InfluxDB, but less often than we see Prometheus, as we mentioned before. So that's kind of the basic architecture. If you guys are looking at what it means to deploy something like this, we will explain in the next few slides how that can be elaborate and really be scalable down the road. But before we go into the more advanced architecture, Ashley mentioned at the beginning that we definitely see security as kind of a neglected child. And I think one of the reasons is if we talked about the DevOps motion, if we talked about the fact that we see the ownership shift from the ops team towards the engineering side, the DevOps teams, I think now we definitely see some kind of similar motion with security. I guess all of you heard about the DevSecOps trend. I think it's still relatively early in the adoption trend, unlike DevOps, but we definitely see DevOps team having the need to check the box or to add some validation on top of their deployments, and that's something that at least having a cloud SIEM solution is something that really helps them address that need. You know, we can talk about a few examples, which I'm sure, you know, all of you are familiar with. I can tell you that, you know, just run an experiment, run a provision a Kubernetes instance in the cloud, and you will see after a few seconds, people are trying to attack it. There are kind of scholars that run over the cloud trying to attack. You know, we know a lot of companies, security companies, that understand that need, understand that challenge, and really provide solution for that. But the need is definitely there. Most if you look at containerized application, in many cases you go to the web, you look for kind of environment or something that you want to deploy. You just take from the web a container, you deploy it in your production environment. It can bring with itself malicious hardware and stuff like this, or software source that can be very dangerous to the organization. So if we look into it, a few things that I wanted to elaborate. So I think that adding cloud SIEM solution into your observability stack, especially if you're working with Elk, shouldn't be too complex. There's some open source that can really help you, like Suricata or Wazoo, that you can fully integrate as a thread enrichment to Logstash that can really help you to build something like this. It does require there is not a lot of dashboard or expertise out there, but it's definitely something that you can start and enrich your data with some of the open source that are available out there. So that's really in a nutshell. And if we look at the architecture slide that we had before, so that's kind of how it looks when you add into it the security piece. You can see over here OSEC, Wazoo, and the kind of how you integrate that into your observability stack. So I want to move forward and kind of talk about how you can really put everything together. And one important thing, and something that I think it takes time to understand, when you look at your observability stack, usually it starts, as Ashley mentioned before, okay, guys, we need to have a log solution. So I just go, I download Elk, I start to deploy it myself. Usually it's really easy to start, but you need to think about those components as kind of production environment that need to be managed, scalable, and monitored by itself. It needs to be it needs to run as a separate environment. And obviously, this is kind of your tools in case that something happens in production environment, and you want to make sure that it runs separately. What you can see here, that's a production checklist that we've put together. Obviously, the first thing is to make sure that the environment is resilient and reliable. You know, I mentioned the need to monitor the environment, the need to make sure that it's up and running and the data is getting into the environment. The second thing is your ability to really scale and get more data. Most companies, successful companies grow in a high rate, especially if we look at DevOps teams, we get more responsibilities, more environments. I can tell you that we moved our kind of monitoring solution from several hundreds of thousands of metrics into many millions of metrics that we're shipping and monitoring internally, and that's part of the growth of the company. And our solution had to be robust enough in order to address that growth and scale. Performance, obviously, it kind of goes without saying, but when you have issue, you can't really wait for latency. You need to make sure that you know how to handle both the performance in case that something happens in production, and now you have high scale of logs or metrics that are shipped to your observability stack, or on the other hand, kind of the interface itself to make sure that it provides a good user experience. High availability, it really depends on how you guys run and operate, but definitely something that you want to look into it. Archiving and backup, it's more relevant if you look at auditing and security, especially if you kind of, if depends on the application itself. Logs, it really depends if you have issues you want to go back and understand, but usually logs you need to retain for less time than the other pillars, unless you have auditing needs. Security, take into account that the solution need to be extremely secured, as depends on the application. Logs may have very sensitive data of the organization. If those can be reached by anyone who get access to your database, then there is a very sensitive information that may leak outside of your organization. So that's kind of a production checklist that you can look at. This is how it looks. That's kind of a simple diagram that adds on top of the previous diagram that we've mentioned. So that's, we look at the ELK stack. You can see that the beats, the agent, the file beat, the Fluentd metric beat that can really ship everything towards AWS in this example. If you run your observability stack on AWS, you definitely want to have a queuing engine in place. Kafka is one of them, at least from what we've seen, the most popular and common one that can really handle those peaks and know how to handle the queue. Logstash, so obviously you need to handle the parsing piece. One of the challenges that we see is that Elasticsearch will not index all the lines of logs that you may ship if it doesn't come in the right format, if it has any characters that it doesn't know how to handle. And that's where Logstash really need to be hardened. You need to make sure that it really works and can know how to address those lines of code, logs. Sometimes that's exactly the line of log that you need when you have issue in production. And then obviously the deployment of Elasticsearch, the multi-nodes to address the scale of the data, and Kibana is the front end. Nginx is being used in most cases as alert engine on top of that. And obviously there is archiving and monitoring on top of that technology stack that you need to have in place. So that's kind of one side of the equation. If you want to make sure that you have kind of multi-regions, you want to make sure that you have redundancy in case of there is an issue in one environment, then it's definitely recommended to replicate that in multiple regions. There is the availability zone flag in Elasticsearch that can really help you with that. Usually, if you were able to do it in one environment, you can replicate. It's relatively easy to replicate that in multiple environments, but just make sure that things like the availability flag is turned on. So that's as for the ELK stack. the diagram. If we look at the Prometheus, so here, as I mentioned before, there's no need to really to set up the shipper. Prometheus itself also have a lot of the Prometheus exporter that can know how to pull data from multiple environments. So it really have a really nice coverage of other environments that it knows how to integrate with. The most popular is the UI is Grafana. Grafana comes with alert mechanism built in. The same does Prometheus. You can use either or. Personally, I'm more familiar with the Grafana alert mechanism, and it's very easy to work with. Obviously, that integrates into PagerDuty, OffGenie, or any other alerting environments that you may have. So that's as for Prometheus. One of the things that you need to take into account with Prometheus is, can you guys hear me? Just, okay. So one of the things you need to take into account with Prometheus is scaling challenges, and those need to be managed properly, especially if you see increase in data. You need to make sure that you have multiple nodes and know how to handle a high scale and high volume of metrics. Usually, from what I've seen, it's not an issue for small teams, but when teams start to have multiple applications or start to ship more metrics, this is where we start to see those challenges. The last piece is the Jaeger architecture. It's more complex. It requires instrumentation of the application. By itself, it brings complexity in deployment. But the rest of the technology piece, which is kind of the Kafka, the Jaeger ingester, and the UI, usually those are very easy to work with. We definitely see and it's pretty impressive to see how Jaeger really becomes slowly the standard. The main reason that I think that's the adoption is due to the fact that it also supports Zipkin, which is also highly used, and we do see a trend to people that starts to adopt Jaeger more often. So that's as for the architecture of the 3 pillars. I want to say a few things maybe before we go to a demo. I think that the fact or the need to have a solid observability stack in place is pay itself. It's not easy, but it definitely pays itself. And you need to understand that that's something that will require your attention, and it takes some time to onboard. And I think if you have nothing, then I would definitely suggest to start with logs, expand to metrics, infrastructure monitoring, application monitoring and metrics, and then to get into tracing. And that's that the fact that we see the open source as the main tool stack that is being used, and to find the right tool for each one of those pillars, that's definitely something that you want to think of before you start the deployment. Understand which one of those alternatives is the right fit for you. So that's from my end. And Ashley, I think if you can take us through a kind of a quick overview that we can show you how it looks, if you're not familiar with Kibana and Grafana, you can see how it looks on our interface, but obviously, as we said before, you can do most of those components by yourself.
Yeah, so just give me 1 second.
By the way, meanwhile, if some of you have questions, so you can either write them as a question. We'll try to answer them towards the end of the session or during. So feel free to ask.
Roy, can you share out your screen?
Do you want me to share my screen?
Yes, please.
Okay, so I'm to show the, okay, so I'm not ready for the demo, so give me a second. If meanwhile someone has question, feel free to ask.
One thing I'm definitely interested in is sort of Elasticsearch evolving to handle more metrics, as you alluded to before. Obviously Prometheus is maybe the de facto tool for doing that within the cloud native stack, but that's certainly comes with its own challenges, especially as it relates to magnitude of data, and then even with lower magnitudes of data, sort of the cardinality of data. Does Elasticsearch potentially offer a better alternative for some of that stuff, or maybe just how do you see them comparing and contrasting? We can also, if the demo's ready now, we can also hold that for the end.
So I don't know. Actually,
I got it.
Okay, I was just presenting my. Yeah. So Brandon, really in a nutshell, I think that metric beat, as I see it, is still limited in many aspects, and from my experience, we've built our solution on top of Elasticsearch, and it did require a lot of development of capabilities on top of Elasticsearch that are not available out of the box. One example is the cost of storing the metrics. So Elasticsearch structure is more expensive, and usually when you want to look at metrics, you want to retain the data over time. So you're not looking just at 2 weeks, you want to look at a year ago, and it gets very expensive. Prometheus has a better way doing that, and we had to develop a roll-up engine on top of Elasticsearch that wasn't part of the capabilities that it has. The second example that I can give you is rate function. Rate function and derivative is highly used when you look at the monitoring solution, and the structure of the database, Elasticsearch database, makes it more complex, and that's another thing that we had to develop on top of Elasticsearch. Just to mention, we chose Elasticsearch because of the challenges that we've seen with Prometheus scalability, but it may be the right solution for specific teams. But when we wanted to look at what we had to support and the way that we had to address that challenge, we thought that the best way for us would be to go with Elasticsearch. There is a new database called the M3DB. In case you haven't heard about it, it's a new open source that was developed internally at Uber, and those guys started their own company, and I think they even got the initial round of funding to develop time series database that support both formats. So that's, I hope it answered the question.
Absolutely, thank you.
Okay, so we thought we would show you guys what some of these open source tools that we talked about look like. They are part of the LogsIO product, so we've taken them and hosted them and added some features on top. So they have the LogsIO flavor, but you'll get the gist of what they look like. So here what you're looking at now is Kibana. This is the front end for the Elk stack that we talked about. You'll see there's a document table which stores all of the logs which are being sent into Elasticsearch. They're parsed out into key value pairs, and that's what's done by Logstash or Fluentd or some of those other shippers that we mentioned. Okay. The next product we talked about was Grafana. So I'm going to open one of our Grafana dashboards for Kubernetes, so you can see what this looks like. This is an example of a Grafana dashboard. So this is monitoring a Kubernetes cluster. You can see the number of running containers, different metrics like memory, and then CPU and memory over time. The idea behind the Grafana dashboards is that you can easily come in here, either after being alerted of an increase over a certain threshold, or just to monitor your environment and check in. And you can see that there was an increase in memory and CPU. From here, we can drill down on just one pod, or come up here and change it to drill in on just one container, or Nginx container, which is having the issues. This gives us a clear idea of what's happening in the environment, although it doesn't give us the full picture. So what I'm going to show now is a LogsIO add-on feature, but the ability to explore out in Kibana and see those log messages that are contributing to that increase. So like we talked about in the observability necessities, you need to use both log messages and metrics. And as Roy just mentioned, starting with logs, you would be able to see this IO exception, but having the metrics as well helps show that there was an issue and then the actual cause of that problem in the log messages. And the last product we talked about today is Jaeger. So this is the Jaeger UI. You can see you can look up by trace ID, choose a service, operation, etc. Filter down on min or max duration, choose the number of results, and then you can find your traces. This will show you the individual transaction, and you can see when there's errors and drill into those, once again, using the logs to see the full picture. Okay, I know we're right up against time. Any questions? Okay.
So I think, Brandon, that was kind of what we had for today. I hope it was helpful and interesting.
Yeah, absolutely. Yeah, one other question I was just kind of holding there in case other folks from the community had questions, but you alluded to sort of the security aspects, particularly around logging. Do you have recommended tools or techniques as far as making sure that sensitive data does not wind up in logs while still maintaining the ability to troubleshoot in those logs?
Ashley, do you want to take it, or you want me?
Sure. Some of the different tools we talked about, particularly Logstash, has functionality to mask or obfuscate and remove data before it's indexed into Elasticsearch. So that's what we would recommend.
Okay. Well, we're at time. If there's other questions, we'll hold on for a couple of minutes here, but want to thank Roy and Ashley and LogsIO very much for the talk today. I think it was a great sort of high-level overview of where the open source ecosystem is today and providing these capabilities. If there's any other questions, feel free to jump in. Otherwise, thank you very much for joining us today, and we'll hope to see you all again virtually next month.
Thank you very much.